following along, or you can just kind of watch the video or take notes on your own. All right, so this is the culminating lesson for the unit, and so what we're going to be talking about is kind of pulling everything together. So the first thing we're going to kind of chat about is classifying data sets. So I'm going to give you 3 different tables, and we're going to show you how you can classify and what they look like to tell what type of function is being represented. So I'm going to zoom in on the first one. So the first one, if you notice, the first thing I want you to notice is pay attention to your x values. So if you notice, my x values are increasing by 10. It's not so much that we have to pay attention to the fact that what they're increasing by, but mostly that they're increasing by the same amount each time. If your inputs or your x values don't increase by the same amount, then we can't really determine what type of function it is. Next, what I want us to look at is we have to check to see how the numbers in the y values or our outputs are changing. So if you remember in exponential functions, how we remember what exponential functions do is there's a common multiplier. Like if we're multiplying 15 by something to get to 12, we're multiplying 12 by something to get to 9, and so forth. The other thing is for linear, you look for if there is, like basically if you're adding or subtracting by the same amount. So in this one, I just wanted you to notice that, so first of all, I noticed that 15 and 12 is a decrease of 3, 12 to 9 is a decrease of 3, 9 to 6 is a decrease of 3. So basically what I noticed is that this is going to represent a linear relationship. We call these numbers here, this -3, -3, -3, we call that our first differences. And so when our first differences are the same number, so they're all -3, that indicates that this is a linear relationship. So this is a linear relationship, and your rationale would be that the first differences are the same. And so that's what a linear relationship will look like in terms of how we'll kind of tell what it is. Let's go to another one. So here you're going to start kind of the same way. You're going to notice that your y or your x values in this case are increasing by a constant amount, and this time it's increasing by 2. You notice how our y values are kind of decreasing really rapidly. Went from 27 to 9, from 9 to 3, and so forth. A lot of times that's an indication of exponential. So remember, exponential is where you're multiplying by a constant amount. So to get from 27 to 9, anytime you're multiplying to get from a bigger number to a smaller number, you should be multiplying by a fraction. So in this case, I'm going to be multiplying by 1/3. And then from 9 to 3, I'm going to multiply by 1/3. And from 3 to 1, I'm multiplying by 1/3. Anytime you have a common ratio, that's what that is right here. When you're multiplying by a constant amount, that represents an exponential function. And so your rationale would be is that you have a common ratio. So you would just say there is a common ratio. And that common ratio just means that you're multiplying by the same amount each time. All right, let me show you one other kind of function. This is the last one we're going to talk about. So I did linear, exponential. This one's going to be quadratic. So again, I want you to notice that your inputs or your x values are increasing this time by the same amount. Could be decreasing, but all of mine are increasing. So we're adding 1 each time. And then if you notice my y values, so a lot of times I can tell from quadratic is that it starts at like 8, 5, 4, kind of decreases and then goes back up 5, 8, 13, 20. Remember what a quadratic looks like, parabola, right? So there should be some sort of like it, starts decreasing and then going back up, or vice versa. So that's kind of a trend in quadratics. So what I'm going to notice is if I go from 8 to 5, that's a decrease of 3. If I go from 5 to 4, it's a decrease of 1. From 4 to 5, it's an increase of 1. From 5 to 8, it's an increase of 3. From 8 to 13, it's an increase of 5. And from 13 to 20, it's an increase of 7. These are our first differences. You won't notice anything special about those. But here's what happens when you have your second differences. From -1 or -3 to -1 is an increase of 2. From -1 to +1 is an increase of 2. And from 1 to 3 is an increase of 2. 3 to 5, 5 to 7. So what you're going to notice anytime there's a quadratic relationship, in addition to kind of seeing that trend a lot of times in the table, you're going to notice that your second differences are all the same. So kind of like linear was the first differences were all the same, in quadratic, so this one's a quadratic relationship, you're going to notice that your second differences are going to be all the same number. So on your practice, we're going to ask that you kind of take a different look at all the different kinds of tables and kind of determine if it's linear, exponential, or quadratic. If it doesn't fall into any of those three, you would just say that it's neither. All right, next. Now we're going to talk about writing equations for exponentials. And what format we're going to use is we're just going to use the y equals ab to the x. So I'm giving you 2 points, 1/6 and 3/54. There's a couple different ways to do this, and I'm going to show you kind of the non-mathy way, I guess, or the non-algebraic way. So the first thing I'm going to do is, what I like to do is kind of make a table. So I know if this is 1/6, I know there has to be a 2 here, and I know there has to be a 3 here, so 3/54. So what I notice, I'm just going to kind of put my numbers in a table. I'm going to go ahead and start with 0. We know that our initial value is always in our table. It denotes, but when our x value is 0. So that's why I'm kind of including that. Our b value is what you're multiplying by to get to the next value, to the next value. So since we know it's exponential, we know we're multiplying by something. So now we just have to kind of figure out what it is that we're multiplying by. So you can play around with it. Maybe it's obvious to you, but what I noticed is that if I multiplied by 3, I would get 18. And if I multiplied this by 3, I'd get to 54. So my pattern seems to be that I'm multiplying by 3. To work backwards to figure out what this starting value is, I would divide by 3 and get 2. And so what I just did here is just kind of filled in the gaps with my table. So now to go over and write my equation, I would use my a value, and again, it shows up on our table at our initial value, so 0. So when x is 0, my y value is 2. Your b value is what your common ratio is, or in other words, what you're multiplying by, raised to the x. And so that's how you would use kind of your table, just kind of guess and check sort of thing to kind of figure out your equation. I'm going to show you a more algebraic way of doing a couple different problems that you may have run across.